Hello guys, welcome to H2O, the A to Z of chemistry. I'm Dr. Ritu Johar, your educator for this crash course on hydrogen, and I hope you've enjoyed the first part from this course. So today we begin with hydrogen crash course lecture number 3. In lecture number 1, what we have already discussed is in detail about hydrogen, its preparation, its properties and uses, hydrogen economy, and along with that we have discussed about the hydrides. In lecture number 2, we discussed about water, a detailed discussion on the structure, the properties of water, and along with the hardness of water. And in fact, maximum questions from water, they are coming from the hardness of water. So that is very important for you, and we have discussed all this with the help of multiple choice questions. So in this lecture as well, where we will be discussing about heavy water and hydrogen peroxide and completing our discussion on the course hydrogen, we are going to do that with the multiple choice questions which have been chosen from the previous year papers of JEE Mains, Advanced, NEET. Along with that, there are going to be few questions from the NCERT exemplar book, and some questions they are going to be from various state competitive examination as well, so that you can have a thorough understanding of what all questions they are important and they are coming in the examination, and at the same time you can revise your concepts from the course hydrogen as well, right? So now all those who have watched my previous lectures, the crash course lecture number 1 and 2, you already know that I have a complete course on hydrogen where we have done a detailed discussion on each and every lecture with 14 lectures, right? So this lecture, when we are going to discuss about heavy water in my course hydrogen was discussed as lecture number 9, and then lecture number 12, 13 and 14 we did a discussion on hydrogen peroxide. All right, and there at the end of those lectures we have put up lecture review questions, and it is actually a collection of these lecture review questions that we are explaining in this crash course hydrogen, so that you can have a revision of your course on hydrogen, right? So all the students who wanted the answers for the lecture review questions, you can also watch this lecture because you're going to get your answers here only, right? So now let us begin our learning today with heavy water. As we begin with the discussion on heavy water, please do remember that if you want to have the details of heavy water, that is going to be my lecture number 8 from the detailed course hydrogen. So let us begin our learning today with the first question on heavy water. Heavy water is H2O18. Second choice is water obtained by the repeated distillation of water. Third is D2O, and fourth is water at 4 degrees Celsius. And this was asked for the IIT examination 1985, and this is a multi-correct question. There are going to be more than one answers which are going to be correct. So let us look at one by one all of these. So H2O18, this means that in this heavy water, we have the heavier isotope of oxygen. The normal isotope of oxygen is going to be O16, and here we are using O18. But actually this is not correct. Heavy water consists of not oxygen's heavier isotope, but it consists of hydrogen's heavier isotope, and the heavier hydrogen isotope is known as deuterium. So heavy water, therefore this is going to be D2O and not H2O18. So two choices. Now you understand this is going to be incorrect and this is going to be correct, right? Now deuterium, this has the mass number 2, whereas the commoner isotope of hydrogen, that is protium, that has mass number 1. So H2O is going to be ordinary water and D2O is going to be heavy water. Now the next option is that water obtained by the repeated distillation of water. Now D2O, you know, this is going to have molecular mass greater than ordinary water, and when the molecular mass is going to be more, the physical constant values for D2O, they are going to be higher than that of water, including the boiling point. What we see is that the boiling point of water, this is 373 Kelvin, whereas for D2O this is going to be 374.4 Kelvin. So there is a difference in the boiling point of the two. So what we can do is we can do a distillation. But when we do a distillation, the boiling points, they're not much different. So what will happen is that if we do a repeated distillation continuously, what will happen is slow and steadily the proportion of D2O in the leftover water is going to be more of D2O as compared to that of ordinary water. So, right? So repeatedly we will be distilling, And with the repeated distillation, what is going to first of all distill is going to be ordinary water, and then D2O is going to follow behind. So after a number of distillations, what we will be getting is heavy water. So this is one way in which we can prepare heavy water. Now the next choice is water at 4 degrees Celsius. So this water at 4 degrees Celsius, this has a higher density than any of the waters, right? So water at maximum density is going to be 4 degrees Celsius. But this is not what we call as heavy water. Okay, so I hope this is clear. So the correct option over here, this is going to be B and C choice. The next question is the speed of the neutrons in a nuclear reactor. This is suppressed by heavy water, ordinary water, mercury and alcohol. So one of the important uses of heavy water is that this is used as a moderator in the nuclear reactors. And what does a moderator do? Well, a moderator, this decreases the speed of the neutrons in a nuclear reactor. Why is the speed of neutrons to be decreased? Well, this is because when the speed of the neutrons is going to be less, it can be easily captured by the fissionable nuclei in the nuclear reactor, and thus the fissionable nuclei, they can undergo the fission process, right? So it is very essential to decrease the speed of the neutrons in a nuclear reactor, and this is done by heavy water, which we use as a moderator in the nuclear reactors, right? So the correct option over here, this is going to be A choice. So the next question is, which of the following statements are correct? So this is going to be a multi-correct question. The choices are heavy water is used as a moderator in nuclear reactors. So let us do this along with the statement only. So heavy water, when it is used to decrease or suppress the speed of the neutrons in a nuclear reactor, it is termed as being a moderator in nuclear reactor. Okay, so this is going to be a correct statement. The next we have is that heavy water, this is more effective a solvent than ordinary water. So this is what you have to remember, that ordinary water and heavy water, they both are capable of dissolving salts, but heavy water is going to be less effective a solvent in comparison to ordinary water. So this is one of the physical properties related to heavy water that you have to remember. All right, the next we have is that heavy water, this is more associated than ordinary water. So what this means is that heavy water, this has stronger hydrogen bonding in comparison to ordinary water, and it is because of this fact that there is more hydrogen bonding in heavy water that the boiling point of heavy water is going to be more than that of ordinary water, right? So this means that intermolecular associations, because of hydrogen bonding, they can be formed more in heavy water in comparison to ordinary water. So this statement is also going to be correct. The next we have is that heavy water, this has lower boiling point than ordinary water, and this is what we have already discussed, that all the physical constant values, they are going to be more for heavy water because of a heavier mass, and therefore the boiling point is also going to be more for heavy water than ordinary water, right? So this was asked in the NCERT exemplar book. So the correct options, they are going to be A and C. The next we have is that heavy water, this is obtained by boiling water, fractional distillation of water, heating hydrogen peroxide, prolonged electrolysis of water. So here what you have to remember is that initially heavy water, this was obtained by the prolonged electrolysis of water. Urey and co-workers, they developed an electrolytic cell in which water's electrolysis was done. When an electrolysis was done, water and heavy water, what is going to be the difference in them is that water, the electrolysis or the chemical reactions for water, which is also going to be the decomposition reaction over here. So water is going to get decomposed on electrolysis to H2 and O2. Hydrogen is going to be liberated at the cathode and oxygen is going to be liberated at the anode. So the electrolysis of water is going to be at a much higher speed than compared to heavy water. Okay, so for all the properties, heavy water is also going to show similar properties as to that of water, but the rate of the reaction is going to be less in compared to ordinary water for heavy water. All right, so the properties, the chemical properties, do remember that they will be just exactly similar to that of water, but the rate of the reaction that is going to be slower in heavy water. So what will happen is during the electrolysis also, water electrolysis is going to be at a much faster speed as compared to heavy water. So after a repeated electrolysis, when we are going to do so many electrolysis and also for a long period of time, from hundreds of liters of water, what we will be getting is just a little ml of heavy water. All right, so that much electrolysis that we have to do, liters of water being electrolyzed and just getting a few ml left behind. So that few ml is going to contain more of heavy water molecules. Okay, so I hope this is clear. So this is how we obtain heavy water. But now, after the development of techniques, fractional distillation came into being, and this is a cheaper way of obtaining heavy water now from water. All right, so this is what you have to remember. Both choices D and B, they are going to be correct. But if we look at your NCERT textbook, so fractional distillation of water is not given over there. So the correct option, if it is a single correct question, this was asked in the AFMC examination. I have not written that down from where it has come. So it was asked in the AFMC examination, and the option given over there which is correct is the D choice. All right, so yeah, it is given over here. So it is AFMC 2001. So the option that is going to be correct is going to be D. But if it is a multi-correct question, please do mark B also to be correct. Fine. So now the last topic for hydrogen, what we have to discuss is hydrogen peroxide. And as far as my detailed course on hydrogen peroxide is concerned, well, it is going to be lecture number 12, 13 and 14, where I have discussed in detail about hydrogen peroxide, where we in lecture number 12, I discussed about the structure and preparation. Then in lecture number 13, the strength of hydrogen peroxide, and lecture number 14, the properties, the uses and some tests related to hydrogen peroxide. So all of you who want after the discussion also some important points to be revised, you can go back to those lectures. So now coming up to the questions. So the first question related to hydrogen peroxide is, which of the following compound is a peroxide? So first of all, you should know what is a peroxide. So the choices given to you are KO2, BaO2, MnO2 and NO2, and this is was asked in All India PMT examination 2010. So peroxide is going to be that compound in which there is going to be at least one oxygen-oxygen single bond linkage. Okay, so the two oxygen atoms should be there which are bound to each other by a single bond. That compound is going to be a peroxide. Now in KO2, okay, one thing more you can remember is that the peroxide, the oxygen atom which are going to be bound to each other by the single covalent bond, they will be having an oxidation state of -1. So in these compounds, you can check the oxidation state. For KO2, the oxidation state of alkali metal is always +1. For the oxygen 2 atoms, the oxidation state is going to come up as -1/2. Okay, so this is not going to be a peroxide. In fact, this is potassium superoxide. O2 -1 is what we have as a superoxide. The next we have is BaO2. So the alkaline earth metals, they always have an oxidation state of +2. So it is going to be +2 and -2x. -2x means oxygen, each oxygen atom will be having an oxidation state of -1. So this is a peroxide. This is barium peroxide. The correct answer, therefore, this is going to be B choice. Now, if you look at MnO2, please do remember that manganese also has +2 oxidation state, but here manganese is not forming a peroxide, this is forming a dioxide. So this is MnO2 with the oxidation state of oxygen being -2, and of manganese this will come up as +4. This is what has been experimentally found out, so you have to remember this. Similarly, in NO2, the oxidation state of nitrogen is going to be +4 and oxygen is going to be -2. So the only option that is correct is barium peroxide, where oxygen is going to have an oxidation state of -1. So the correct option is B option. Now the next we have is the oxide that gives H2O2 on treatment with a dilute acid is PbO2, Na2O2, MnO2, TiO2. IIT 1985, this question was asked. Well, if you just check on the preparation of hydrogen peroxide, the reaction is not given over here, where sodium peroxide, the correct option is going to be sodium peroxide. So sodium peroxide, this reacts with dilute acid. For example, it is a dilute H2SO4. So on reaction, it is going to give us H2O2 plus sodium sulfate. All right. So whatever is going to be a peroxide on reaction with a dilute acid, this can give us hydrogen peroxide. Okay, so from these, one thing that you can identify is that sodium peroxide, here the oxidation state of oxygen will come up as -1. So this is going to be sodium peroxide, and this on reaction with dilute acid, this will be giving us H2O2. So this is one way. And the other way is that you should remember this reaction also, the process by which sodium peroxide reacts with dilute H2SO4 to give us hydrogen peroxide along with that sodium sulfate. This is called as Merck's process. The reaction is not given in the NCRT textbook, but there is one question related to this reaction in the NCRT exemplar book. So it was a must that you should know this reaction. Okay, so that is why it is very important for you to know this reaction. If you want more details on this, you can again watch my lecture number 12. Now the next we have, so the choice is going to be B choice. The next we have is that the oxidation states of the most electronegative element in the products of the reaction, barium peroxide. This is barium peroxide, we've just now done this. So barium peroxide with dilute H2SO4, there are 0 and -1, -1 and -2, -2 and 0, -2 and +1, and this was asked for the IIT examination 1991. Right, so barium peroxide, when this is going to react with dilute H2SO4, just like sodium peroxide reacting with dilute H2SO4, we will be getting H2O2 and barium sulfate. Here we got sodium sulfate, so a similarity in the reaction. Okay, so in H2O2, the oxidation number of the most electronegative element, that is going to be oxygen, is going to be -1. And in barium sulfate, the oxidation number of oxygen is going to be -2. So the correct option is going to be B option. But now there are certain things which I want you to remember related to this reaction. First of all, we are not going to use anhydrous barium oxide. We use hydrated barium hydroxide. Oh, sorry, barium peroxide. Okay. Why it is so is because once barium sulfate will be forming, it will form a protective layer on the barium oxide if it is going to be anhydrous, and then the reaction will not proceed further. Another thing is that barium sulfate, this is going to form white precipitates which we can remove by filtration. But what will happen is that some of the barium sulfate, this does not get completely precipitated. And if barium sulfate remains behind in the solution of H2O2, this can cause the decomposition of the hydrogen peroxide solution. Okay, this is one thing that you have to remember. So what we can do is, instead of using dilute H2SO4, we can use dilute phosphoric acid. We can use carbonic acid, or carbonic acid, what you have to do is, you have hydrated barium peroxide. You will be making an icy cold paste of this, and then you will be passing carbon dioxide through this. So it is going to be either a dilute phosphoric acid which we can use, or pass carbon dioxide through it, rather than using dilute H2SO4. Okay, so these are things that you have to remember related to this reaction. So hydrogen peroxide, the next question is that this can be obtained by the electrolysis of water, H2SO4, HCl, fused Na2O2, and a question asked in the NCRT exemplar book. Now this is a very important reaction by which we can industrially prepare hydrogen peroxide. What we do is the electrolysis of H2SO4 solution, 2 moles of H2SO4. They will be giving us at the cathode hydrogen gas, and on the anode what we will be getting is H2S2O8, that is the Marshall's acid. Marshall's acid on further hydrolysis, that means reaction with water, will be giving us back H2SO4, which we can use again for the electrolysis purpose, and along with that hydrogen peroxide is prepared. Okay, this is how we proceed with the reaction of the electrolysis of H2SO4. In case you want to have a detailed understanding of the reaction, please go back to lecture number 12. Right, along with this, one more thing which I want you to remember is there is one more way in which we can prepare hydrogen peroxide industrially, and that is by the auto oxidation of 2-ethyl anthraquinol. Okay, in that reaction, what you have to remember is that we take as a substrate or a reactant 2-ethyl anthraquinone, that is, quinone means one with a carbonyl group. On reduction with hydrogen, what we get from that is alcohol. So 2-ethyl anthraquinol, OL. And on auto oxidation, that means on reaction with oxygen of the air by itself, we are not doing anything. What we will be getting back is 2-ethyl anthraquinone, and along with that hydrogen peroxide will be prepared. So this is also one very important reaction which is not being covered in these questions, but you have to remember that as well. So you can go back to your NCERT textbook, read that again, or you can go back to my lecture number 12. Next we have the storage of, so the correct option is going to be B option. The next question is H2O2. This is stored in, a very important question, although it is not coming in a question examination, but it is stored in plastic containers after the addition of a stabilizer. It is stored in iron containers after the addition of a stabilizer, glass containers after the addition of stabilizer, in any container of metal or glass. So hydrogen peroxide, this is a very unstable compound. It decomposes to water and oxygen. And what the things that can cause decomposition that are very important. First of all, on long standing, it is going to decompose by itself. On heating, it is going to get decomposed. Then in presence of light, it gets decomposed. In presence of any metal, glass, alkali, it gets decomposed. In presence of rough surfaces, dust, this can also cause the decomposition reaction. So how are we going to prevent that decomposition? Because we are storing it, we want to store it in the intact form. So what we do is we store it in plastic containers and plastic dark bottles we generally store it in. And after the addition of a stabilizer, the stabilizer can be urea, it can be acetanilide, it can be glycerol, which are going to prevent the decomposition reaction. So the correct option is going to be A option. Okay, and one more thing, if you want to store it in glass bottles, we can do that also in dark glass bottles after a wax coating of the glass surface, so that the glass does not interfere in the decomposition, cause the decomposition of hydrogen peroxide. The next question is, from the following you have to choose the incorrect statement about hydrogen peroxide. So one by one, let us read the statements and do it. It can act as an oxidizing agent. Okay, so this is something that I will be discussing in detail in the next coming up lectures, where we will be not lectures, sorry, in the next coming up questions, where we will be talking about the chemical properties of hydrogen peroxide. But just remember, H2O2, this can act as an oxidizing agent as well as a reducing agent. The next is, it decomposes on exposure to light. So this I have already told you that it is going to decompose into water and oxygen. It has to be stored in plastic bottles. So this is also correct. Or it has to be stored in wax lined glass bottles in the dark, so that light does not cause a decomposition, glass does not cause a decomposition. It has to be kept away from dark. No, it has to be kept in dark. So the correct options are going to be option number B and C, and the incorrect ones are going to be A and D. So the correct answer is going to be A and D. And this was JEE Mains 2015 examination question. So next we discuss the strength of hydrogen peroxide, and here what is going to be important for you is what is volume strength. So volume strength of hydrogen peroxide, this will be the volume of oxygen liberated at STP by the decomposition of one volume of that sample of hydrogen peroxide. For example, this means is that if we have a 25 volume H2O2, this would mean one volume of hydrogen peroxide solution will give 25 volume of oxygen gas at STP. If it is going to be 1 liter of H2O2, we will be getting 25 liters of oxygen. If it is going to be 1 ml of H2O2, it will be giving us 25 ml of oxygen gas. Okay, and STP, I hope you all know, this is 273 Kelvin and 1 atmospheric pressure. All right, now the decomposition reaction also, please do remember, because this is important for all the calculations. So 2 moles of H2O2, this will be giving 1 mole of oxygen and 2 moles of water. So we have done the detailed calculations in my lecture number 13 from the course hydrogen, where you will find how we derived all the relationship between volume strength, percentage strength, molarity and normality. But here I'm going to just give you the shortcuts for that. All right, and the shortcuts are that percentage strength, this is going to be 17 by 56 into volume strength. Molarity is going to be volume strength divided by 11.2, and normality is going to be volume strength divided by 5.6. How we have reached these values, this is something you can go back to my lecture, detailed lecture, and you can see over there if you need that. So now let us do a few questions based upon this. So the first question is the volume strength of 1 molar H2O2 with the molar mass of H2O2 being 34 gram per mole. This is going to be equal to 5.6, 16.8, 11.35, 22.4, and this was asked in the JEE Mains January 2019 examination. So just now what you have studied is that the relationship of molarity and volume strength is that molarity is going to be equal to volume strength divided by 11.2. So we are given over here 1 molar solution, so 1 into 11.2 will be equal to the volume strength, that will be 11.2. So the most approximate answer over here, this is going to be C choice. So the correct answer is C choice. The next we have is the strength of 11.2 volume solution of H2O2 with the molar mass of hydrogen being 1 gram per mole and oxygen being 16 gram per mole. The choices are 3.4%, 1.7%, 13.6, 31.6%, 34%, and again the question asked in the JEE Mains January 2019 examination. Now we are requiring the percentage strength to the volume strength relationship. So percentage strength is going to be 17 by 56 into volume strength. Put the values, you will be getting the percentage strength to be equal to 3.4%. So the correct answer is going to be A. The next question is, what is the volume of 20 volume H2O2 required to get 5000 centimeter cube of oxygen at STP? And this was asked for the Karnataka engineering students entrance examination. The choices are 100 centimeter cube, 125 centimeter cube, 250 centimeter cube, and 50 centimeter cube. Now what 20 volumes H2O2 means is that 1 centimeter cube of hydrogen peroxide solution, this gives us 20 centimeter cube of oxygen gas at STP. So 20 centimeter cube of oxygen at STP will be equal to 1 centimeter cube of H2O2. 5000 centimeter cube is going to be 1 by 20 into 5000. So this is going to be 250 centimeter cube of hydrogen peroxide. So the correct option is going to be C option. The next question is commercial sample of hydrogen peroxide. Many questions they have been coming from this topic in the examination. So please do this very well. Commercial sample of hydrogen peroxide labeled as 10V. Its strength is nearly 3%, 6%, 9%, 12%. And the question asked at the West Bengal JEE 2014. So percentage strength, again this is 17 by 56 into volume strength. So you will be getting on calculation the approximate percentage strength to be 3%. So the correct option is going to be A choice. The next we have volume strength of 1.5 normal H2O2 solution is 4.8, 8.43 and 8, and this was asked for the IIT entrance examination 1991. So again the relationship between normality and volume strength. So normality is going to be volume strength divided by 5.6 and volume strength therefore will be equal to 1.5 into 5.6. So the value comes up to 8.4. So the correct option is going to be B option. So finally, I come up to the last topic of our today's discussion, and that is going to be the properties of hydrogen peroxide. In my detailed lecture, I have discussed the physical properties, the chemical properties, the tests and uses of hydrogen peroxide. But here I'm just going to chiefly focus on one very important property of hydrogen peroxide, that is the chemical property, and that is going to be the oxidizing and reducing character of hydrogen peroxide, because most of the questions from this topic they are coming from there. For the rest of the things you can go back to my lecture number 14, that is the concluding lecture from hydrogen. So the chemical nature of hydrogen peroxide is, the choices given to you are oxidizing agent in acidic medium but not in basic medium, reducing agent in basic medium but not in acidic medium, oxidizing and reducing agent in acidic medium but not in basic medium, oxidizing and reducing agent in both acidic as well as basic medium. So the question was asked for the JEE Mains 2019 examination, and here what you have to remember is that H2O2, this is going to act as an oxidizing as well as reducing agent in both acidic as well as basic medium. There are few reactions which are given in the NCERT textbook. I have given in my detailed lecture many reactions which are going to explain you how hydrogen peroxide this behaves as an oxidizing and reducing agent in both acidic as well as basic medium. Okay, and there are going to be certain things that are discussed over there, which are the applications of these properties, the uses of hydrogen peroxide based upon the chemical properties of hydrogen peroxide. So you can go back and quickly look at that lecture also, so to have a thorough learning. Okay, but now here actually what I want to do is a trick related to the oxidizing and reducing properties, so that you can do your questions very well even if you forget the reactions, because there were so many reactions. So I wanted you to learn a trick for that. Okay, and before you can learn the trick, what I'm going to do is I'm just going to write down the decomposition reaction of hydrogen peroxide, because that is something that is very easy to remember. Okay, so just now in the volume strength you saw that hydrogen peroxide, this decomposes to water and oxygen. So if you write the oxidation state of oxygen in this, for hydrogen peroxide, the oxidation state is going to be -1. For water, it is going to be -2. And for oxygen in the elemental form, it is going to be 0. So from -1 to -2, hydrogen peroxide is going to be what happening? It is going to be reduced. Okay. So wherever in the reactions hydrogen peroxide is getting converted into water, what is going to it act as? It will be acting as an oxidizing agent. Right? And if we see this part, it is going to be an increase in oxidation number. So hydrogen peroxide is getting oxidized. So it will be acting as a reducing agent. So wherever in the products you see that oxygen is being evolved, please do remember that hydrogen peroxide, this will be acting as a reducing agent. So when H2O2 is getting converted into water, and along with that water, or it is OH ions, because in OH ions also oxygen is going to be in -2 oxidation state, right? So whenever H2O2 in the reactions is getting converted either into water or into OH ions, it is going to act as an oxidizing agent. And whenever oxygen is being evolved in the products, it is going to act as a reducing agent. This is what you have to remember, even if you forget the reactions and you have to choose that hydrogen peroxide is acting as what in these reactions. So it is going to be easy for you people to just look at the reaction and write your answer and save a lot of time. So let me show you now the questions related to this that I have chosen. So the correct option for this one was the D choice. Which of the following equations depicts the reducing nature of hydrogen peroxide? So reducing nature is going to be when oxygen is going to be evolved. Okay, so let us see the question. So there are 4 reactions, 4 options for you. These are going to be very important reactions. Actually, you should know these reactions, but in case you forget them or you do not have time over there, one thing that is very important, the trick is just to quickly look at the products. In the products, in the A, you have just water. So here it is going to be a oxidation. H2O2 is going to act as an oxidizing agent. Okay. The next we have is that in this reaction, what is being evolved? So water is being there, but now oxygen is also being evolved. So when oxygen is going to be evolved, it is going to act as a reducing agent. Okay. So correct option till now, it is going to be B option. The next we have is H2O2 being converting into OH ions. So OH ions, it is going to be the oxidizing character. And H2O2 into water, again it is going to be the oxidizing character of hydrogen peroxide. So the correct option is going to be B option. So just looking at the products, even if you have forgotten the reactions or you have less time, please do this way. Okay, so your answer is going to be correct. So before we conclude today's lecture, let us see two more questions which is going to explain you and master and remember what I have just now told you. So consider the reactions HOCl plus H2O2 forming hydronium ions, chloride ions and oxygen ions, H2O2 plus Hi forming I2 plus water. So here what is you have to tell is which statement is correct about hydrogen peroxide. So it is an oxidizing agent in both A and B, and oxidizing agent in A, reducing agent in B, a reducing agent in A, oxidizing agent in B, a reducing agent in both A and B. So here what are you going to again look at? H2O2 getting converted into water. So this is going to be an example of oxidizing character of hydrogen peroxide. Oxygen is -1, 2, it is going to be -2. So hydrogen peroxide is getting reduced and it will be therefore acting as an oxidizing agent. In the second part, it is H2O2 to oxygen. So again, it is -1 to 0. -1 to 0 means H2O2 is getting oxidized because the oxidation number is increasing, therefore this is acting as a reducing agent. So for H2O2 to water, it is going to act as an oxidizing agent. H2O2 to oxygen, it is going to act as a reducing agent. So the correct option is going to be B option. Let us look one more question. Which of the following equations depict the oxidizing nature of hydrogen peroxide? Again, four reactions are given to you. All these reactions, they are themselves very important reactions. You should actually remember these reactions, okay? But as this is the crash course, the only thing I can tell you is at this moment that even if you forget the reactions, please do not forget what I have just now told you. All right, so the fourth choice is also given and you have to tell what? You have to tell whether hydrogen peroxide is acting as an oxidizing agent in which of these reactions. So when it is going to act as an oxidizing agent, it is going to get either converted into water or it is going to get converted into OH ions. So here oxygen is being evolved, oxygen is being evolved, oxygen is being evolved. The only reaction where we are getting OH ions is the C option. So the correct option is going to be C choice. Okay, so that would be all for this course on hydrogen peroxide. So I think you must have enjoyed learning today about hydrogen. You have done so many questions. You've practiced actually so many questions, and along with that, you have revised your very important concepts related to hydrogen and its compounds. So if you want more courses from us, please do join us at H2O Chemistry. And also if you have any doubts still left from this course, or if you have any doubts related to chemistry, please do feel free, mail them us to at h2ochemistry@gmail.com. Put them in the comment section. Also do join us on the Facebook page of the channel. The Facebook page has the same name that the channel itself, that is H2O Chemistry. So see you again for more courses. Bye bye for now.